So one of the applications for exponentials is exponential growth. So here we've seen this formula before. P of t is equal to P ERT. P in this case is the initial population. E is just 2.71 approximately. R is the rate of growth, and T is a time. So for example, if we had human population, it can be exponentially growing, and time can be in terms of years. And then we would have to have an initial population, and then the exponential growth number, so the E. So I'm gonna go ahead and use this formula for these problems. So here's the first example. So a culture starts with 8,600 bacteria. After 1 hour, the count is 10,000. So at what rate is the bacteria growing? Round to 4 decimal places. So one of the things that we're looking for here is the rate. So the rate in this case, if I look back up, rate is just labeled as R as a decimal. So we're looking for what R is. I don't know what R is. Now it starts initially with 8,600 bacteria. So this is just P, our initial amount. 1 hour is just going to be the time, T, and then 10,000 is just going to be what we have after 1 hour. So P after 1 hour. Okay, so let's write down our formula. So our formula is going to be P of t is equal to P ERT. So we know what T is. T is just 1. So P of 1 is equal to P. P is 8,600. E to the power of R. R, I don't know what that is. And then T is just going to be 1 hour. Okay. So I'm going to have P of 1. P of 1 in this case is just going to be 10,000. Right? Because that's the population after 1 hour. Is equal to 8,600 e to the power of r, because r times 1 is just gives me r. Okay, now let's figure out what r is. So let's divide this by 8,600 to both sides. Divide by 8,600. This goes away, and I have e to the r is equal to 10,000 divided by 8,600. Now, in order for me to solve for this r, because r is up in the sky, so I need to figure out what r is going to be. So how am I going to get rid of this e? So in order for me to get rid of this e, what we got to do is apply a natural log to both sides. Okay, so remember that the natural log is the thing that has the base of e, so I'm going to add an ln to both sides. Okay, and then I'm going to have e to the r, and then I'm going to have 10,000 over 8,600. Okay, so this r is going to go to the front. I have r. ln of e is just equal to 1, so we have r times 1 is equal to ln of 10,000 over 8,600. R times 1 is just going to give me r, and what is this going to be equal to? So that's just something that we put in our calculator. So ln of 10,000 divided by 8,600 is going to give me 0.1508. Okay, so that is going to be my rate. So this is as a decimal. Okay, so that's my rate. The rate at which it's growing. So it's about 15.08%. Okay. All right, so now how much bacteria is present after 5 hours? So round to the nearest whole number. Okay, so we're still going to be using the same formula. So P of t is equal to PERT. Okay, so what is given to us? Now I know what t is, because this is 5 hours. T is just going to be 5 hours. I'm looking for how much bacteria is after 5 hours. So I'm basically looking for this thing. So how much bacteria is there after 5 hours? Now P, do we know what P is? Yeah, that the initial amount hasn't changed, 8,600. E to the power of R. R, we just figured out what that was, just 0.1508. And then T is just going to be 5, the 5 hours. So all we really got to do to figure out what P of 5 is just going to be plugging all of this into our calculator. Okay, so this is going to be 8,600 E to the power of 0.1508 times 5. Okay, and what I'm going to get approximately is 18,279. About that amount. Okay, now one thing to be very careful with, and I'll put it in red, what I see a lot is this. I see a lot of this. Divide by 5, P equals whatever. That's not what we want. That's not right. Do not do. Well, we'll do not do that. Okay? So remember, P of 5 has a special meaning. P of 5 means it's a population at 5 hours. So it doesn't mean the population times 5 is the population at 5 hours. Okay, so don't do that. I will give you no points if you do something like that. Okay, regardless if your answer was correct. Okay, so just don't do that. Okay, so here's my last question about how many hours will the number of bacteria double? Okay, so for this one, we're still using the same exact formula. We're still using P of t is equal to P E R T. So we're looking for time. I don't know what time is. I still know what my rate is. My rate is still 0.1508. We know it's still our initial population, 8,600. Okay, now we want to figure out, okay, at what time? So what should the time be when the population doubles? So what is the doubling size? So we don't know what t is. The doubling size will be when it's 2 times 8,600, because that's what doubling is. Okay, so when I do 2 times 8,600, what I'm going to get is 17,200. That's what I'm going to end up getting. Okay, so all we got to figure out is just my time. So P of t is just going to be this 17,200. P initially is just 8,600. Okay, then e to the power of r, that's just 0.1508 times t. Okay, and what we got to find is just t. Okay, so since t is up in the sky, I need to isolate this exponential. So let's move this 8,600. So I'm going to divide by 8,600 to both sides. So this is going to go away. 17,200 divided by 8,600 is just going to give me 2. Is equal to e to the 0.1508 t. Okay. Now I need to get rid of that e. So what do we got to do? Apply ln to both sides. Okay. All right. So when I apply an ln to both sides of 2e 0.1508 t, this thing is going to go to the front. So I'm going to have, let me write it here. Let me write this. So what I'm going to have is just going to be 0.1508 t. ln of e is just going to be 1. Is equal to ln of 2. Now, in order for me to solve for t, I just got to divide by the 0.1508. 0.1508. So t is going to be approximately how much? So in how long will this happen? So ln of 2 divided by 0.1508. What I ended up getting is about 4.6. And what is this? Is this hours, minutes? What was this? This is hours. Okay, so about 4.6 hours, my bacterial is going to double. Okay. All right. So hopefully this made a little bit of sense. You can go ahead and replay this video if you need a little bit more help, and I'm gonna do another example in the next one.